Here is the next example. In this example, he's asking about the total current supplied by the source as well as current passing through this 20 ohm resistor. I will ask one more thing. Also find voltage across this Vx. Okay, so here he's asking us three quantities: I, Vx and Ix. So the first thing we need to do is we need to find the total resistance. Then only we can find the current supplied by the source. So to find the current, to find the total resistance, you need to find which elements are in series, which elements are in parallel. So as I mentioned, always start from the resistor which is far away from the source. So if I start from 13, it's kind of hard for me to tell whether this is parallel with 12 ohm or 24 ohm or series with it. So the current is going to come over here. For sure it's not in series because current is going to divide. Not the same current is passing through 13 and 12. So they are not in series. Or the same current is passing through 13 and 24. They are not in series. So it's hard to find when you start solving the example from the resistor which is closer to the source. So always start from the resistor which is far away from the source. So is 60 parallel with something or series with something? Now if you feel like it's hard to define, then move to the other resistor. Now 20 ohm. It's easy if I label the resistors. Let me label them: R1, R2, R3, 4, 5, 6 and 7. Now if I move to R6, I can clearly see R6 series with R5. I'm going to label that as R8. R8 equal to R5 plus R6, which is 20 plus 20, 40 ohm. Now if I replace this with 40 ohm, let me redraw. It's a good idea to redraw the circuit, not for every step, but at least for every 2 steps. That way it makes it easier for you. Okay, so this is 24, 40 and 60. Okay, so this is R8, R7, R4. Okay, R2, R3, R1. Now I can clearly see R8 parallel with R7 because both of them are separating at the same node or rejoining at the same node. Actually, even R4 is also in parallel with it because all three of them are dividing at this point, or all three nodes are connected at this point. All the three elements, other ends of all three elements connected at this node. But for time being, I'm going to go over R8 parallel with R7. Let me label that as R9. So R9 equal to 40 times 60 over 40 plus 60, which is 24 ohm. Okay, now I'm drawing the circuit for every calculation, but as I mentioned, you don't need to do that. Okay, so this is R9 and this is R4. Okay, now these two I can clearly see they are in parallel. I'm going to label them as R10. R10 equal to R4 parallel with R9. Now both of them are 24 ohms, right? So if you remember in my previous video, I told you if same resistors are connected in parallel, that resistance value divided by number of resistors will give you resultant value, that is 12 ohms. Now here is a little bit harder part. Now here is 13 ohms, 12 ohms, 12 ohms and 24 ohms. Okay, so this is R1, R2, R3 and R10. Now which elements are connected in series, which elements are connected in parallel? Okay, remember, if the same current is passing through them, they are connected in series, right? So whatever the current, I current comes there and it's going to split I2 and I3. Okay, same I2 is going to come over there I2, and same I2 is going to come over here. So when it comes here, it's going to be I. So R2 series with R10. Okay, I'm going to label that as R11. R11 equal to 24 ohm. Okay, now you may ask why I2 is coming from that direction. Why not this I3, whatever I3 comes there, I3, why not it go back in this direction? It will not, because the property of the current is it always flow from higher potential to lower potential. So whatever current started from here, this I ampere, it want to come back to this negative terminal. So I3 will never go back in other direction. I3 will definitely come towards the negative terminal. So that's the reason I'm showing I2 is coming down, I3 is also turning towards the negative terminal. Okay, now so that's the reason R2 and R10 are also in series. Okay, so now I have R1, R3, R11. Okay, now here is the total circuit. I can clearly see R3 parallel with R11, which is 24 parallel with 24. We just did that. 24 divided by 2, which is 12 ohms. Now R total equal to, I'm going to label this as R12. Okay, R total equal to R1 plus R12. Okay, I have 13 plus 12. This is 13 ohms, right? Which is 25 ohm. And we have V as 100 volt. Okay, so now I can tell I equal to 100 divided by 25, 4 ampere. Okay, now to solve the individual parts, okay, you need to go back from here to the passing through each circuit, okay, to find out the individual currents or voltages. So 4 ampere is going to come here and it's going to split, right? So here is 24 ohm, here is 24 ohm. All I care for current passing through in that direction. So each resistance is same value, for sure the current is going to divide equally. Or you can use the current division rule. By using current division rule, I11 equal to total current multiplied by opposite resistance over total resistance. So based on this formula, I can tell the current passing through this R11 is 2 ampere. Now going back again here, so I can clearly see this is 2 ampere, this is 2 ampere. Okay, that's what we just found, right? Again, I'm going back to the previous. Now I can see 2 ampere current is going there because it is 4 ampere. I mean from the previous circuit, from this circuit, that's how I'm writing the current values, okay, and 2 amperes is going there. Now what happens there? Again, current is going to divide. They both of them are the same values. So I4, I can use the same current division rule, 2 times 24 divided by opposite resistance, which is R9 divided by R9 plus R4. Okay, so based on this, I can tell that is 1 ampere, this is 1 ampere. Okay, now I'm going back again. Do you remember our goal is finding Vx there? I already know the current passing through that, which is 1 ampere. So what is Vx? Vx must be 1 ampere times 24. So that's a 24 volt. Vx equal to 24 volt. Now, if we go back to the original circuit, so here this is 4 amperes. Out of 4, 2 amperes is going here, 2 ampere. Again, that 2 ampere is going to divide 1 ampere and 1 ampere. That's what we found. Now our goal is finding Ix. So in this case, Ix equal to, can I write Ix equal to the total current, which is 1 ampere, times opposite resistance, which is R7, over R5 plus R6 plus R7. These two are in series. Okay, the Ix is going to depend not only R6, it's going to depend upon both resistors. So 1 times 60 divided by 60 plus 20 plus 20, which is 40. Okay, so 60 divided by 100, which is 0.6 ampere. So the current here must be 0.6 ampere. So out of 1 ampere, 0.6 is going in the direction, the remaining 0.4 must go in the other resistor. Okay, so this is how you solve for current and voltages, and you can find power also across, or power consumed by any element in this circuit by using this method. So this is called series parallel combination method. Okay, I'll stop this video here, solve more examples in the next video. Thank you.